Like the hat? So that hat has a long story, and I'll remove it. I'll not be able to give the talk otherwise. And so the hat comes from a dear friend, community member for a while, co-organizer of this talk, which is Sebastian Lorenz. But maybe first I should introduce myself. I'm Michael Arnaldi. I'm the original author of Effect. That's clearly not me. That's what I refer to as the Backstreet Boys version of Sebastian Lorenz. That's the only reason I have this slide, by the way. I had to wear the hat and kind of make fun of myself. I was like, now everybody's gonna make fun of him. So, to begin this talk, I first want to say thank you to everyone, starting to thank the organizers, the other speakers, the attendees, no attendees equal no conference. The venue managers, they've been amazing. This venue is truly exceptional. Catherine, I've enjoyed eating so much. The sponsors, yes, of course, and everyone else. Funny that we also sponsored the conference, and I forgot to thank you, the sponsors. But really, thank you a lot. So, as I said before, that's the second version of Effect Days, and a year went by. It flew over. We've got new team members that today have been officially announced that are welcome to join officially. And last year, it was about Effect being close to production readiness. Was used in production already for a while, but we had the very first stable version of Effect to bring to the wider TypeScript ecosystem. And as Johannes said this morning, the metrics since then have improved a lot, and Effect has been used for many more use cases. A lot of brilliant production-grade usage from both small and large companies. Today we've got a lot of talks about how Effect is currently used in some critical systems. And one of the things I'm most proud of is that in pretty much any of the talk about using Effect in production, you could see a similar picture about an open telemetry set of spans. That means Effect really gives the power to those people to observe what's going on in those production-grade systems, to improve, and so on and so forth. So where are we today? Today we are close to make stable what I would call the layer 1 level of the ecosystem. That means platform, CLI, SQL, RPC, and so on and so forth. They're more and more ready for prime time and ready for production usage. And we've got amazing talks from Maxwell and team this morning about what's coming next at the ecosystem level with the AI packages that are in alpha now, and with the cluster package that has reached alpha, which again, to quote Ethan Nizer, that means it's stable enough to be deployed in all production grade and critical systems. Of course, bug-free as much as possible. But really, what my talk is about has nothing to do with this, and has more to do with what we've learned from the community and from those production-grade users during the last year, and how we are trying to incorporate the feedback into what's coming next. So what is next? Well, today I'm gonna talk about Effect 4.0, codename smol. Come on. So to be clear, we are nowhere near ready to release Effect 4.0. This is a talk about the current state, what we've been doing, and what's still left to be done. And I'm gonna be honest, some of the things you're gonna see today, they might not end up being implemented at the end, or we might have more features than what we show today. But I sort of wanted to show where our thinking goes. So I'm straight after this talk, I'm gonna open access to the repository, which is called Effectful, and you can try it. It's not gonna be published, so just to avoid people like Patrick Rosa to use it in production, we avoid publishing it. So at least you have to run the code locally, build it by your own, and if you wanna destroy your systems, go ahead, please. So the first thing that we've heard from the wider TypeScript community is Effect is big. And it's big, especially in use cases where bundle size matters, like front-end. For this reason, we had to create a specialized module, which is called micro in the current version of Effect. But after having created micro and having done the research on micro, I'm famous to always ask why. And I started asking to my team, why does Effect need to exist and micro needs to exist? Isn't that enough to get the baseline of micro and extend from there? Can we make Effect as small as micro? And I'm happy to say that, of course I have to learn how to use a laptop, but I have to increase font size probably. This is building up a few examples that are also built in every one of our PRs. So we're keeping track of the bundle size growth and basic usage of Effect, which includes the runtime. It's a very simple program just to test out the basics. This is about 5.4 kilobytes, which is less than the current size of micro. And this is feature complete. That means Effect is now much more tree shakeable than it was before. And as we add features, such as, for example, batching and so on and so forth, loggers, you see that the bundle size increases, but even a very feature complete usage, such as schema, is now around 17K. It used to be more than 50. So that's a huge improvement in bundle size. Well, that's why the code name smol. One of the other questions that we asked ourselves is related to the current runtime, and it is, are fiber references, runtime flags, and context all needed? Or can we get away with just context? Because if we can get away with just context, we're gonna, one, improve bundle size, because there's less madness going on, and point two, we don't have to clone objects once we fork new fibers. We can just reuse the same context object, given that it is immutable, and that should be a huge speed up. Well, the answer is yes, we definitely can, and in the new version of Effect, you will not have fiber references, you will have context references. Context references are just services with a default. So you can use a context reference without the context being affected with the type of the service, and they have a default, and the defaults are cached globally. So if they are initialized at any point in the lifetime of your program, they're never going to be reinitialized twice. But you can override that. And to prove the point, I've built a small program that uses, I thought a future flag would be a good way of demoing this. And here, obviously, we can see that the program runs first with the default, with the feature flag disabled. Then we locally provide the service, and it becomes enabled. Then another thing that has hurted many users in the worst possible way has been subtyping. And this is something we went back and forth a little bit, but while building Effect, we thought what a great idea would be to make option a subtype of effect, to make either a subtype of effect, to make everything a subtype of effect, which means you can yield them in a generator and you can use them just like you would use normal effects. But this feature paired with flattening, so functions like and then, for example, where you can pass both a function that returns an effect or that returns a normal value, you'd get surprising behavior because that would auto-flatten, for example, a reference, and you would get the value instead of the reference. So in 4.0, we are testing with the concept of yieldability instead of subtyping, which means stuff like options are not directly effects, but are convertible into effects, and you can still use them normally inside a generator. Let me see this. So here, I have a program, and you can see in this program, I'm doing the same type of code that I would write today. I'm yielding effect.write, I'm yielding effect.sum, and this returns effect void. Of course, I'm not actually returning anything, but then you have the no such element error, which is coming from the option. But those are not directly effects anymore. And in fact, if I do this, I'll get a type error. So to use them outside of a generator, you'll have to say as effect, and they become normal effects. This helps preventing conflict together with auto-flattening while still allowing you to use them as normal values inside a generator, which we think is the right balance between ease of usage and safety. In current version, we have far too many queues. There, and that's something that has been going on over time. We figure new stuff, we don't want to break old stuff, and we add stuff. And that means we currently have 500 different ways of doing the same thing. At the beginning, Q was directly ported from Zio, and there's a little bit of over-engineering behind the scenes. And in the lifetime of 3.0, we've extended Q with a different module, which is called Mailbox. And that module also, it's like a queue with 2 parameters. You can also raise an error. It's more feature complete. For example, when you derive a stream out of a queue, you would usually derive a stream from a queue of exit values. There's really no way of finalizing a queue, pushing a final element to a queue and doing stuff like that. And it's all in Mailbox. And Mailbox also turns out to be much more performant. And it's internally built using plain JS data structures that are way more performant than what we could ever achieve with custom data structures using that are currently used in Q. So the new Q is just Mailbox, with removing the 500 ways of doing the same thing, and I'm gonna demonstrate how new queues look like. As you can see, you can create a normal unbounded queue. You can omit the second argument, and you just get the plain old queue of a number, but the second parameter is never. If I specify the second parameter, it becomes the second parameter of the queue, which is the potential error type that you can push into the queue. Can offer elements just normally, but then you can say that the queue is done or just end the queue. You can be done with a failure, or you can be done with an interrupt. You can be done with any element. If you're done with a void, the queue is declared as ended. And when you pull from the queue, so when you take elements, you've got the choice of defining what behavior you really want. Just to prove this is supposed to be working. And it does. And I think I even have a benchmark somewhere. Let me check. Yeah, it's still called Mailbox, you see. So I just want to run this benchmark to let you see the performance. So here we are pushing 1 million of elements into the queue, and then we're taking the 1 million of elements from the queue, and we're repeating this. In average, we take 32 milliseconds to push 1 million elements into the queue, and 85, around 80 to take 1 million elements out of the queue. With the old implementation, this would have taken probably a second, more or less. That means things can get faster. We've re-encoded everything. Quite literally, I don't think there is even a single data type that we haven't rebuilt from scratch. That means fiber is tiny, schedule is tiny, layer is tiny, a lot more performant than it used to be. So you'll be able to provide layers locally without any concern for performance or bundle overhead. They add less than a kilobyte to the final bundle size. Channel, which is the underpinning module that stream is based on, has been completely re-encoded. And channel is also very lightweight. And by consequence, stream is also very lightweight. How did we do that? Most of those types were implemented using a technique which is called executable encoding, or initial encoding, which is declarative encoding. And that means we would have a series of fixed operations and build everything else on top of those set of fixed operations, and then have a runtime that ends up interpreting those operations. Now, all of those are built straight up on top of Effect with an executable encoding, or also known as final encoding, which is supposed to be way more performant and way more lightweight. And let me show you what I mean by slightly more performant. I have here an example, and I'm producing a stream of 100,000 elements, and I'm mapping effectively over the stream with a concurrency of 10. That means I'm going to have 10 concurrently running fibers that process each element independently. So currently this takes about 170 milliseconds. But now a little surprise. You can, by the way, see API compatibility. Now I'm just using old Effect. So migrating to this new version will hopefully not be such a big effort in consumer code. I want to ask you a question. How much do you think this program will take using the old Effect version? An hour and a half, I don't know. That's 3.2 seconds. That's about that's about 20x perform. Bun. No, I'm not gonna run this on Bun. Sorry, Jared. I want to say something. We're not cheating. We have not rewrote the internals of effect in Go. So that's a 20x improvement just on top of TypeScript. We just used a small tool which is called TeamSmart to optimize this. And maybe if I find it, yes, stream here. Let me actually open. Let me take just my last PR, for example, where we run all the tests. Stream is 6.6 kilobytes, 3-shaked. So not only is 20x faster, it's around 20x smaller too. In the lifetime of 3.0, we thought the use case of batching queries would be so important that we decided to support this in core. But we took the ideas from ZioQuery, and I've hacked those ideas into the effect fiber. The reality is that the model of concurrency and the model of batching kind of were fighting between each other, which is why you have, when you do with concurrency or you do for each and so on and so forth, you have two options to enable. You have concurrency to enable, and you have batching to enable. You can batch without concurrency, you can do concurrency without batching. And the reason really is, one, batching was implemented in this odd way, where basically it would violate the lifetime of a fiber. It would stop an effect from execution. It would save the state, batch the requests, and then restart the effect in a different fiber than the original one. So you could do batching with no concurrency at all. The second reason is fibers used to be slow, or used to be less free than they are currently are. With effect smol, with 4.0, we asked ourselves, can we unify the two things? Can we just have batching be made on top of fibers? So you would have, for each with unbounded concurrency, you would have all the operations awaiting on the requests to be resolved. Much easier to use patterns like data loaders. You can batch over 500 milliseconds and do all sort of time-based batching stuff without getting crazy with building custom resolvers. And the answer is yes, absolutely. Thanks to the fibers being faster and smaller, we can 100% do so. And I want to show you a program. So this program batches 100,000 different calls to a get user ID. But if you see now, I can do just like something like pipe and say resolver dot set delay effect dot sleep 100 millis. No, effect dot set delay. Why doesn't this? What am I doing wrong? Duration. Set delay, it's just a duration, yes. There was a set delay effect, I'm not out of my mind yet. So yes, you can also do with a direct delay of 100 millis. And this would batch everything that happens within 100 milliseconds, regardless of where it's coming from in your program. That means batching is no longer restricted to occur on a single for each call. Not yet. Not yet. Here I'm benchmarking the same program. Keep in mind, this program runs 100,000 fibers concurrently. I think in average it takes, let's see if I can calculate the average before this ends. I think it's about 140 something, 150 milliseconds. And in 150 milliseconds, we are forking 100,000 fibers, resolving 100,000 requests, and yielding the response back. Again, the tool of use was TeamSmart. This case, the tool of use is me. We've heard this morning from Ethan about the STM module. It's an extremely powerful module, which is absurdly underutilized. The reason it's underutilized is that it's not effect. And you have to learn a new module, you have to read further documentation, you have to fight with the restrictions of STM, like not being able to run effects inside STM, and not having functions like log, having a different environment. When you use STM, you never know if you should export your type as an STM or as an effect. The idea is very simple. The idea for STM stands for Software Transactional Memory, is basically you want transactions which can be repeated over and over again until they succeed and they run optimistically. So those are repeated transactions. They are the equivalent in software than database transactions would be on databases. And we've been able to merge the power of STM inside Effect in the first place. So you will have modules like TXRef, which is a transactional reference. You can just create the transactional reference normally. Here we are forking a program that every 100 milliseconds updates the value of the TXRef. And here we are declaring an effect transaction that accesses the STM value, the transactional reference value. If it's less than 10, it logs something using normal effect.log, and it yields a retry transaction, which will instruct the transaction entity to restart anytime any of the accessed values change. If the value is 10, then we're just logging fine, and the transaction is supposed to close. So hopefully, if I run this and I haven't pushed any bug in the last 48 hours, I haven't wrote any code, so it's very hard, but never know, demo god. This runs 10 times, and the 10th time just returns. That means you're going to be able to use STM all over the place to do coordination, synchronization between processes, and so on and so forth in a much easier and more accessible way. Basically have to document a single function and a few sets of modules that you can use. And transactional modules, we have transactional reference, we have transactional queues, we have transactional maps, we have transactional chunks, and so on and so forth. This is an odd thing that I think many of you expected to work already, which is unresolved fibers keeps the process alive. And that means this program, let me ask you, do you know what's the result of this with old? If I run this program, what should I expect?
It quits immediately. I saw that on the stream.
There you go, nothing, absolutely nothing. That's counterintuitive. The reason is there's no longer any work to do. There are no handlers pushed in the event loop, and JavaScript thinks everything is done. And I can't tell you how many times I had Johannes pushing screenshots to my DMs with some red arrows and say, what is going on here? We all know that. Now it hangs the process, which also means you have to pay more attention to interrupt, because if you hang some fibers around, your program is going to keep running. But this is a very, again, detailed element, but I think the current semantic is much better than what it used to be. Less surprises all over the place. Here, I've already shown the channel and stream example, but having re-encoded every module, and here, like, Maxwell has done tons of work on schedule. Like, the work has been going on for months and months. Everything is literally as efficient and fast as possible currently. So I don't know if I have any other example for this. I think I was supposed to run the stream program at this point in time. I've done it before, so I won't bother you again with this. But maybe let me show the schedule re-encoding that again I was supposed to show later. But here we have schedule with Cron. Cron is an amazing addition, almost useless, but Sebastian has spent a lot of time on it. And he was very, very insistent on having me tell you that now Cron supports time zones too. What I wanted to show in this example, apart from the obvious, very important cron module, is that schedule now tracks errors explicitly. Before, schedule did not track errors explicitly, was assumed to be a never-failing type, and now those types are correctly propagated back into the main effect. So you'll be able to build schedules that can fail. No reason to do that unless you're implementing cron for no use case whatsoever. This is the price of buying me a hat. More implicit handling of scope. I've been asked, I think, 1 million of times in Discord, I'm using this like layer.unwrap effect, a piece of code, gigantic piece of code, and I have scope in my requirements. How? Why? Well, you didn't have to use unwrap effect, you had to use unwrap scoped. And you did not have to use layer.effect, but you had to use layer.scoped. Very happy to tell you now that you can just use layer effect, you can just use layer unwrap effect, and the scope is implicitly handled. You're not gonna leak scopes everywhere. So again, less surprises, more good defaults. The cron was still running. It's a very persistent module. Basically, it sort of does the job, and when the program ends, it's so this program is using. We haven't ported yet effect.service, which we will in the future. But what this is doing is creating a background fiber that increments a counter every 100 milliseconds, and then my main program reads the current count after 500 milliseconds. So I get 0 and 5, no surprise. But when the program ends, you can see there's no scope needed here. I provide this layer, and everything works out of the box. The fiber is killed. The proof that the fiber is killed is that the program does not hang, thanks to the feature before that I've shown before. And in general, I mentioned this before, less ways of doing the same thing. We're also consolidating the ways of creating tags into only effect.service with a few more options to enable all the different use cases. And this is pretty much where we currently are. Effect is functioning, there's a lot of passing tests, but we still have to do a lot of stuff. And here I literally mean a lot of different things. Namely, we still have to implement stack traces, we still have to implement metrics, we have to unify caching, because we have about 7 different ways of creating cached effects. We are re-evaluating once again if to rename either into result. A lot of people are gonna be happy about this. Personally, I dislike this change. I hate it with all of my body, but I'm not the only one using effect. If we rename either as a result, we are thinking about making exit a result of either A. You see, either is more general. A result of either A or cause E. We're trying to make structure equal structure by default. So if you don't use the data module to create an object, they are compared by default using structural equality. What's hard here is to avoid circularity, because a generic object might be circular and the structural version kind of loops. We have some ideas how to restrict this problem. The idea is generally to have plain objects being structural, but as soon as you use a class, by default it's going to be referential. So if the prototype is not the default prototype, it's going to be referential, unless you use, of course, data.tag class, data.class, and the data functions where you are explicitly tapping into structurality. As I said before, we have to port effect and make it more generic. We have to port the remaining module. Effect is very big. We have to redesign some of the STM data structures with the new encoding and actually make them usable, because some of the data structures that we currently have in STM don't really make a lot of sense in JavaScript. We have to consolidate API names. I haven't shown any of the new names on purpose because we're still not certain, but we are trying to improve everything, like catch all what. We're trying to make that something like catch all errors, catch all failures, something around that tells you a little bit more of the functionality you are tapping into. And we are also evaluating if to memoize layers in between provides, because we've seen many people use effect provide multiple times in their application tree and layers being recreated. We want layers to be memoized from the topmost of the provide. Those may not happen, or they may. and who knows what else. Tentative timeline, probably gonna take around 3 months to release a beta of this. 3 months further to port the ecosystem projects. This hopefully it's not a lot of work, given that we aim for close to API compatibility. And to be honest, to dog food a little bit on the new effect version. And so we expect 6 months in total for a stable release. And Effect 3.0 is stable. So we plan to keep supporting Effect 3.0 for a while before everything diverges into 4.0. We are thinking about a 6 months timeline after the release has been declared production ready to give people enough time to migrate. And I think my feeling is that 4.x will be the first LTS version of Effect. Because this time we have really learned from production usage. We restarted from scratch, reevaluating all of the core choices. Once we are stable with this, I honestly would have no idea what to change in the short term. So thank you, and see you next year, hopefully, where I will announce that Effect 4.0 is long-term support. And just to avoid, I haven't done that for a while. This repository is currently public. Have fun.